Hello everyone. As we know that in the previous lecture we discussed the different types of weathering. Physical, there are actually two types of weathering that was discussed in the previous lecture. One is physical weathering and another is chemical weathering. Weathering was discussed in the last lecture, and in this lecture we are going to discuss the chemical weathering. First we need to know what is the chemical weathering. Chemical weathering is actually the process of rocks of the crust, alteration of the rocks of the crust by chemical decomposition brought about by the atmospheric gases and the moisture. It's actually the chemical reaction that takes place between the rock surfaces and the gases that are present in the atmosphere. The gas may be carbon dioxide, it may be nitrogen, hydrogen, or it may be oxygen. As we know that rocks are made up of minerals, all of which are not in chemical equilibrium with the atmosphere around them. Chemical weathering is the essentially a process of chemical reactions between the surface of rocks and the atmospheric gases in the direction of establishing a chemical equilibrium. The end product, the resultant product of the chemical weathering, has a different chemical composition and a poorer physical composition as compared to that of the parent rock. Chemical weathering actually eats up the rocks in number of ways depending upon the mineralogical composition and the nature of the chemical environment surrounding them. The main processes of the chemical weathering are: one is solution, hydration and hydrolysis, oxidation and reduction, carbonation, base exchange, and formation of colloids. In solution, some rocks contain one or more minerals that are soluble in water to some extent. For example, you may take the example of rock salt, gypsum, or calcite. As we all are, as we all are aware of the fact that pure water is not a good solvent of minerals in most cases, but when the water is carbonated, its solvent action is enhanced. Hence, we can say that carbonated when water is carbonated, its solvent action for common minerals it's enhanced. Another is hydration and hydrolysis. These two processes indicate the direct attack of atmospheric moisture on the individual minerals of the rock that ultimately affects its structural makeup. It's believed that though interior of many minerals is in electrical equilibrium, the surface of many crystals are not. They may have partially unsatisfied valencies. When polarized water molecules come in contact with such crystals, it may cause any one of the following reactions. First, the ions tend to hold the polarized side of the water molecule and form a hydrate. Another is ions may be exchanged, whereby some ions from water may enter into the crystal lattice of the mineral. Third is oxidation and reduction. Iron is the chief constituent of many minerals and rocks. The iron bearing minerals and hence rocks are especially prone to chemical weathering through the process of oxidation and reduction. Another is carbonation. It is the process of weathering of rocks under the combined action of atmospheric carbon dioxide and moisture, which on combination form a mildly reacting carbonic acid. This acid formed exerts a specially corrosive action over a number of silicate bearing rocks. Now, another topic is what are the factors that affect the weathering. First one is nature of the rock. As we know that rocks vary in chemical composition and physical constitution. Some rocks are easily affected by weathering process in a particular environment, whereas others may get slightly affected, and still others may remain totally unaffected under the same conditions. It depends upon the what is the chemical composition of the rock. Thus, for example, of granite and sandstones exposed to atmosphere simultaneously in the same or adjoining areas having hot and humid climate. The sandstone will resist weathering to a greater extent because they are made up of mainly quartz, that is silica dioxide, which is highly weathering resistant minerals. Granites, on the other hand, are likely to undergo a lot of chemical decay due to carbonation, hydration, and hydrolysis. Hence, chemical composition of rock is an important factor in determining the stability or otherwise of the rock in a given environment. Second is climate. The process of weathering is closely related to climatic conditions prevailing in a certain area. Same types of rocks exposed in three or more types of climates may show entirely different tones of weathering. Thus, cold and humid conditions favor both chemical and mechanical types of weathering, whereas in totally dry and cold climates, neither chemical nor mechanical weathering may be quite conspicuous due to the absence of moisture. Similarly, in the hot and humid climates, chemical weathering process predominate, whereas in hot and dry climates, mechanical breakdown due to expansion and contraction, as already discussed, of the rocks at the surface may be more pronounced. Now, the third is the physical environment. The topography of the area where rocks are directly exposed to the atmosphere also affects the rate of weathering to a good extent. Next is what are the when weathering occurs, what types of products are formed. Actually, when weathering takes place or when decay of the rock takes place, two products are formed or two types of products are formed. One is alluvium, another is delirium. Alluvium is the end product of weathering that happens to lie over and above the parent rock. It may consist of fragmentary material resulting from the rock disintegration or fine powdered material resulting from the chemical decomposition or mixture of both. Delirium is that category of the end product that has been moved some distance after its formation due to the weathering process. That means alluvium remains at its place, while as delirium is taken from that place to another place. It is Delirium is invariably associated with weathering of slopes and forms heaps of various thickness and grade at the base of the erosion. It is rather a broader term signifying the breakdown of rocks of the crust by such natural agencies that are characterized with some motion as wind, running water, and moving ice. By virtue of their velocity, these agents are not only gradually disintegrate the rocks but also remove the broken particles and fragments to far off distances ranging from few meters to hundreds and thousands of kilometers. Rivers originating in the Himalayas take along with them particles and fragments broken down from the rocks of their channels and sides to the lower plains and even to the sea, where some of them may ultimately reach. Similarly, winds blowing over deserts and dry loose soils, removing thousands of tons of these materials from one place to another and ultimately deposit them in far off areas. Another term is denudation. Denudation is derived from the Latin word denudare, meaning to uncover. It's a general term expressing the sum total of the process of weathering and erosion operating for a geological time in a certain region. That means it's the combination of weathering and erosion. A denuded landscape is the one that has been produced and is presently exposed as a proof of the collective work of the agencies operating in that area. For example, a river valley which is presently much wider than maximum width of the river flowing through it cannot be attributed to the erosion work of the river alone. The process of weathering operating on its sides has also contributed a lot in its widening. The debris resulting from the slopes due to the weathering has been contributed to and washed away by the river. Most of the valley slopes and hence valleys are the features of the denudation. That is, they have been exposed to and modified by combined action of weathering, rainwash. And now our next topic is geological work of the wind. As we know, atmosphere is mainly composed of gases that are collectively known as air. Air, when set in motion, is called as wind. Wind is one of the three major agents of the change on the surface of the earth, other two being rivers and glaciers. The origin, movement, and classification of winds are all meteorological topics. In general, it may be said that winds are born mainly due to non uniform heating of the surface of the earth at different places, causing differences in the atmospheric pressure. The pressure difference so created makes the atmospheric gases, that's the air, to move from areas of high pressure to the areas of the low pressure in the form of winds. During such movement, wind may create temporary or semi permanent changes on the land surface. These changes manifest themselves in the form of some surface features their exact nature depending on wind volume, wind velocity, nature of the surface over which the wind blows, duration of time for which it blows, and so on. Thus, strong winds blowing over loose ground, dry soils, or deserts may create many temporary new features within the short span of the time, whereas very strong wind blowing over the vast areas covered with dense vegetation may not affect the original topography at all for any length of the time. Winds act as an erosion, as a carrier for transporting materials, particles, and grains so eroded from one place, and also for depositing huge quantities of such wind blown material at different places. The three principal modes of activity, that's erosion, transportation, and deposition by wind, are discussed in the next section. First is wind erosion. Wind performs the work of erosion by three methods. One is deflation, derived from the Latin word deflare, meaning to blow away. Another is wind aberration, and the third one is iteration by the wind. First is deflation. Wind does not possess much erosive power over the rocks or over the ground covered with vegetation. But when this wind moves with a sufficient velocity over dry and loose sands or bare ground covered with dust, it can remove or sweep away huge quantities of loose material from the surface. This process of removal of the particles of the dust and sand by strong winds is called as deflation. It is the main process of the wind erosion in desert regions. In fact, in some deserts, deflation may cause the removal of the sand from a particular location to such an extent that big enough depression is created, sometimes with its base touching the water table at a quite depth. Such depressions are called as blowouts.